Hi guys, this is lesson 6.4. Today we're going to be talking about non-linear functions. So a graph of a linear function shows a constant rate. So a linear function shows a constant rate of change. A non-linear function does not have a constant rate of change, not non-linear. So it is not a line, okay? So just to remember that if it's not a line, if it does not have a constant rate of change, it is nonlinear function. Identifying functions from a table. Does the table represent a linear or nonlinear function? To explain. So remember, constant rate of change describes a quantity that changes by equal amounts over equal intervals. So in this one, my x's, I'm adding 3 every single time. For my y's, I'm subtracting 8 every time. So as x increases by 3, y decreases by 8. The rate of change is constant, meaning it's the same. So since it is constant, the function is linear. So this is a linear function. Now in this one, I'm adding 2 on the x's. But if you notice my y's, I'm adding 9, then I'm adding 22, and I'm adding 55. So as x increases by 2, y increases by different amounts. So the rate of change is not constant. So the function is non-linear. That's one word. All right. So you want to check just like we talked about in our previous lessons. Now, identifying functions from graphs. Does the graph represent a linear or a nonlinear function? The graph is not a line, so the function is nonlinear. It has to be a straight line at a constant rate, and it cannot be vertical. Remember, if it's vertical, it's not a function. So this is nonlinear. The graph is a line, even though it's horizontal, it is a line, and this is a linear function. Okay, so what I would like you to do is you can either write it here or you can turn to a couple pages and do it on the blank sheet on your own problems. Write if the table or graph is linear or nonlinear and explain. So go ahead and pause and next, we're going to check those in just a minute. Next, I'm identifying a nonlinear function. So it asks which equation represents a nonlinear function. And it gives you all these different choices. You can rewrite the equations y equals 4 7/10, y equals pi x, and y equals 4 times the quantity of x minus 1 in slope-intercept form. So they are linear functions. Okay, so this one we would just have to finish our distributive property to get it in slope-intercept form. You cannot rewrite the function y equals 4 divided by x in slope-intercept form, so it is nonlinear. The correct answer is C. C is nonlinear. Okay, now we have a real-life application. Account A earns simple interest. Account B earns compound interest. The table shows the balances for 5 years. Graph the data and compare the graphs. So here you have your table of the different amounts, and they've graphed it. So at 0, you are starting at 100 on both of them. After 1 year, you're at 110 for both of them. At 2 years, one of them, account A, is 120, and the other one's 121. So you're just $1 difference. And then by year 3, you're at 130 and $133.10. On the 4th year, account A is 140 and account B is 146 and 41 cents. And then fifth year, account A is $150 and account B is $161.05. And those would continue to grow. Both graphs show that the balances are positive and increasing. The balance of account A has a constant rate of change of $10. Every time it is changing or increasing at $10. So the function representing the balance of account A is linear. The balance of account B increases by different amounts each year. Because the rate of change is not constant, the function representing the balance of account A or account B is nonlinear. Because it's not constant, it is not linear. And you notice it kind of got it curving up here. So that's going to be a curved line, not a straight line. Please do on your own, and you can do those right over here on the other side so you have enough room to explain. Does the equation represent a linear or nonlinear function? And again, explain. So do 4, 5, and 6. Okay, go ahead and check your on your own answers. These are the answers that you should have had for on your own 1 through 6. So go ahead and take a minute, check those, make sure that you understand why they were linear or nonlinear, and make sure you could describe those and explain them. And once you are done with that, you may move on to the next part of the module.